Today, I'm doing a simple experiment to show how paint creates color. Before we start, what do you think happens when we mix this color? Make a guess. This happens because pigments in paint absorb some colors of light and reflect others. Mixing pigments changes what light gets reflected, so the color changes. So, this experiment shows that paint colors come from how pigments absorb and reflect light. Isn't it simple and fun?
This is turmeric, and its yellow color comes from a natural pigment called curcumin. You are probably wondering why we are talking about curcumin and turmeric, right? So today, we're going to see how natural pigment like curcumin change color based on pH. So let's get started with the experiment. Curcumin is actually a pH indicator. That means its color changes depending on the environment, whether it is acidic or alkaline. In water, it stays yellow. When I add baking soda, which is alkaline, the molecular shape of curcumin changes shape, so it absorbs light differently and turns orange-red. What happened if I add lemon? If I add lemon again, the mixture becomes acidic and the color turns back to yellow. This shows how molecular structure controls color. So yes, kung pun ada chemistry, natural pigment like curcumin show color through real molecular shape.
Hello everyone. Today I will carry out a fabric dyeing experiment using food coloring and white fabric. Along the way, I will explain the basic chemistry behind how the dye molecules diffuse into the fabric and why the color become permanent. Let's get started. First, I mix warm water with a small amount of vinegar and a red food coloring. Warm water speeds up the movement of the dye molecule while the vinegar stabilizes the color. I damp the fabric, soak it for 10 to 20 minutes to allow diffusion into the fibers. And finally, rinse it with cold water to remove unbound dye. And let's bring this experiment to a close. We have seen how dye molecules move into the fabric and why the color becomes stable after the process. Thank you for your time, and I hope this explanation brings in understanding the chemistry behind fabric dyeing. Thank you.
The green color appears because of red and blue wavelengths from the sunlight reflecting green wavelengths back into our eyes. A simple experiment allows students to observe how light passes the leaf and how chlorophyll affected the green color of our eyes.
The purpose of this experiment is to explain how chlorophyll creates the green color in leaves.
We can understand that green color is not accidental, but it is a result of how pigments interact with light.
Leaves look green because of chlorophyll. Chlorophyll absorbs most color of light, especially red and blue, but it does not absorb the green light. It reflects it, and because of the reflected color enter our eyes, the leaf appear green to us. So, in conclusion, leaves are green because chlorophyll reflects green wavelengths of light while absorbing the others.
Leaves are like tiny living canvases that work tirelessly to capture sunlight and transform it into energy. Behind their calming green color lies an important pigment called chlorophyll. This pigment is more than just a natural dye, it functions as a plant light-absorbing engine that makes photosynthesis possible.
Did you know when you boil purple cabbage, you can get a natural color changing indicator? And what happens when this purple solution meets lemon or baking soda? Let's find out with a quick experiment with me. For this experiment, I'm going to label each cup as cup A and cup B. Lemon juice will be placed in cup A, whereas baking soda will be placed in cup B. This happens because natural pigment in purple cabbage contains anthocyanin. Alkaline environment removes more hydrogen and changes it into green or blue color, while acidic environment adds more hydrogen so that it becomes pink color. That's all from me. I hope you learned something by this experiment. Bye!